Very good morning, one and all. I am going to deliver the lecture about the this foundation and stresses, Unit 5. So these are all the content in the Unit 5. Allowable stresses in bearings, slab base, gusset base, types of trusses, economical spacing of roof trusses, and the loads combination in the roof trusses acting on the wind load acting on roof trusses, and design of purlins and also the roof trusses. So these are all the content in Unit 5, and this is the course objective of this unit, and these are all the text and reference books. So introduction part, in this we initially in this class we should know what is meant by stresses and what are all the important characteristics and advantages and disadvantages of the roof stresses. So we all know this is the one type of stress members. So in this we have a lot of components are available. So what is meant by rafter, purlin, shed, struts and roofs, principal rafters, common rafters, tie beams. So these are all the main elements in the roof trusses. So today we will discuss some of the factors. Introduction part. Just we would like to explain about the introduction part. Why we need the roof trusses, what are the factors affecting the roof trusses, and advantages and disadvantages of the roof trusses, and main component of roof trusses, various terms we are using in the roof trusses, types of roof trusses, and the covering materials. So today we will discuss the introduction part, right? So what does mean by the truss members? If a frame structure in which the separate straight members are arranged and connected at their end, and the member form a triangle which lies in the same plane. So this is the normal explanation. Normally if you are providing for more than 6 meters, the roof trusses are providing for an industrial shades, the ceiling for the large rooms and auditoriums, cinema hall, marriage halls, and godowns. So this will be using as a roof trusses. The members are carrying compressive force in roof truss is known as struts. What will be carrying the tensile forces? This is a tie member. So this carrying compressive force is carried by the strut member. The tensile force is carried by the tie members. So these are all the some example roof truss are used in practical sections, practical applications. So we will discuss the component of roof trusses. We know we have two main component. We can classify it into two category. One is main member, another one is secondary member. So what will do the main member? This main member will do the carrying the load and distributing the load, and finally it will provide the stability also. What will do the secondary member? This member will provide the stability to the primary member. So this is the one example. So this is the bottom, this is the top. So this is bottom chord member, this is top chord member. In this intermediate section, this is called a web member, right? So why we need roof trusses? We have some requirements, right? So it will provide the daylight requirement, and also required more headrooms. The height, it should be mentioned by the height, and more headrooms and more clear span availability. We should provide roof trusses without internal supports. That is the one major advantage. So there is no provision for internal supports, then only we prefer the roof. That is why we are preferring roof trusses, and it reduce the attic moisture and provide the proper ventilation also. The light load on structures, there is less chances to excess bending and shear forces. So these are all the need of the roof truss members, and these are all the factors that affecting the selections of roof trusses. What are all the factors? So these factors may be the span of the truss member, and the pitch of the truss member, maximum natural light requirements, how much naturally the light requirements are getting are available. So we have to keep this in mind. That factor also affecting the roof truss, and the rainfall. That's the one most important thing that will be. We have to consider this factor as a main factor, right? So covering material. If we are providing roof truss means what will be the covering material we are going to adapt, and which style of your home. What is the style for of that we are going to apply the roof trusses, and availability of the funds. So depends upon the funding. Then only we'll decide how much of amount is spending for the proper adequacy of the roof trusses. And the types of building, which type of, this is steel, RCC, wooden beams, wooden structure, whatever it may be, this it depends upon the type of the building also. And the state building code, we have to follow the building codes and the functionality. If we RCC means we have know the code, and also steel where IS 800 we should know, right? So based on this building codes, we have to adopt the roof truss and functionality and aesthetic view. That is the main important thing. Finally, the emergency energy efficiency. The energy efficiency should be in proper manner. So these are all the factors that affecting the roof trusses. And what is the advantages and disadvantages of the roof trusses? So we have, as of we know, if we are having any advantage, the also some disadvantages also there. It's suitable for sloping roof. Mainly it is for applicable only the sloping roof, and suitable for light load and large span. it permitting it permitting variety of roof spaces and providing greater vertical spans, most economical for a spanning of 6 meter. We have different criteria, different types of roof trusses are available, but in the 6 meter we can get the economical section, dead load of the structure. So these are all the main advantages. What will be the disadvantage means, the problems is in the our transportation. That is a very big issue of the each and every person working in a site. So aesthetic appearance of the roof is very low. So if we are providing any kind of structure means that will be very low, and wooden roofs are susceptible to be fire. It should be affected by the fire, right? It is a cost is high, and also it's a maybe a corrosion problem also there. So these are all the some disadvantages. So these are all the main terms used in the steel roof trusses. We know the span, center to center span or end to end distance, and the raise, what is the height and pitch and slope, and purlins, we are providing purlins here and rafters here, and sheetings, above that the sheetings and panels are providing base, how many base are we are providing, and rigid line principal rafters, and camper rafters also principal rafters, and eaves, the point of eave. So these are all the main terms we are using in the steel roof structures. So next we will move to the types of steel roof structures. We have, when the span exceeds 10 meter, the timber trusses become very heavy and it's an uneconomical section. That's why we are preferring from 6 meter onwards, we are preferring steel trusses for economical purpose, and also we are applicable for large span structures. These steel structures are mainly fabricated by the rolled steel sections. So it can be used for roof trusses in the sections of channels, angles and T sections. So this is the one part. We can use these any type of sections. In the rolled steel section, we have I-beam, T-beam, angle, channels and plates. So in this section, we can prefer any kind of section, especially the most of the roof trusses and fabricated from angle section, because they can resist efficiently both tension as well as the compression forces. So that is the main purpose if we are adapting for angle sections. Then steel trusses may be grouped into the following category. It may be open, north light and bowstring. So these are all the main category and types. So these are all some another images. We all know it is a king post, queen post, and it is a scissors, and it is a raised cord trusses, simple link truss and house trusses. So these are all the simple example of the different types of trusses. And these are all the another one, compound trusses, the compound link, compound house, compound fan. These are all the other type of trusses. And knot lights, these are all the main, that is a open, another one is a knot light. The knot light trusses, so it's sawtooth and bearing shed, and knot light trusses, modified knot light, and bowstring knot light, bowstring trusses. This is called bowstring trusses, like a bowl shape. So this is a bowstring trusses. So these are all the different types of the steel structures, steel roof structures. So this is the practical example of showing different type of structures, steel truss roof structures. First, initially, we have to each and everyone know about the king post trusses. What does mean by king post roof trusses? Based on the length condition, it may be vary. The king post does consist of, we have a tie beam and principal rafter. Two inclined principal rafters are also provided in this king post, and two struts are also provided, and one king post is there. So this is the example point of view. This is the king post. First, initially we have to know this is the king post, and two struts, this one strut, this one strut. And this is the principal rafter. This is the one rafter and this is the one rafter. This is the principal rafter and this is the purlin, right? So this is the tie beam, joist beam, tie beam. This beam is called as a tie beam. So one king post, two straight, two principal rafter, and another one is tie beam. So these are all the main factors, main terms using the king post. So in this king post, usually king post truss is only limited 3 meters center to center. The truss suitable for the span varying 5 to 8 meters, it may be very suitable for applicable for king post trusses. The principal rafters joined to the tie beam. Principal rafters joined to the tie beam. A single abutment, the tension joint by a brittle joint. Maybe this joint can be tension joint. So this inclined structure, that is called principal rafter. The horizontal member is called tie. So both are connecting at one point. That is called brittle joints or tenon joints. We can say like this. So the king post is provided with the splayed shoulders and feet and this tenon into the upper edge to the tie beam of sufficient distance. We have to provide this kind of regions of sufficient distances. So this is the practical example of king post stresses. So this is the another one image. It shows the tie member, straight member, purlins and principal rafters and king post also. Next one is queen post. So instead of two vertical posts rather than one, that is called queen, the vertical posts are known as a queen post. The top of the which are connected by the horizontal piece known as a straining beam. Absence of straining sill, the thrust from the strut would tend to force the foot of the queen post into. The trusses are suitable for 8 to 12 meter. The king post is suitable for 5 to 8 meter. This is 8 to 12 meter. So this is a one varying from king and queen post. This is the one example of the queen post trusses. So we have two in compare straining beams also here provided. This is the main example difference between the king post and queen post. On strut is provided here. This is the our principal rafter. This is tie member. This is the queen post. So one compared to the king post, the only one king post other is this will be having two queen post here. This is the same principal rafter, purlin, etc. The other conditions are same. This is the example of queen post and king post. The very simple variation between king post and queen post. So this is the example of queen post structures. We know some of the covering materials are available. Still now we are using this material as a covering material, right? One is trusses, portals, slabs, dooms, AC sheet covering, GI sheet covering, shingles and slates. So these are also main roof covering material for providing roof trusses. So that's all the introduction part. So this is the course outcome of this unit and design of column based roof truss and considering wind load as per IS 875. So thank you so much.